Welcome to the Defense and Aerospace Report. I'm Vagan Radian here at the Association of the United States Army's annual meeting and trade show in Washington, D.C. Our coverage here is sponsored by AM General, Elbit Systems of America, General Motors Hydrotech, L3 Technologies, and Leonardo DRS. And we're over here at the QinetiQ North America stand to talk to John Hastie, who is a product manager for applique and large unmanned ground systems. And John, I think that's a pretty large unmanned ground system behind you.
Yes, this would be our Titan vehicle. So this is a 2,500-pound unmanned ground vehicle for dismounted troop support.
And you guys have been developing, you guys have a lot of expertise, everything from very small robots, much larger robots, to something in this class range. Talk to us specifically about this. I mean, as an armor fan, as a fan of history, I mean, it has a lot reminiscent to the World War I, to the original tanks, actually, the rhomboid British Army tanks from 1916. Talk to us a little bit about, what shapes the design, and what's the application you guys are shooting for? Obviously, it's a cargo application.
Well, the system you see here today is a cargo application, but what really shapes the design is modularity. So the system is made up of a series of modules, so you have a left and a right track module. Within those modules, you have all the power, drivetrain, and control electronics. What that means is the center payload bay over here is actually open and simple and replaceable. So within about 5 minutes, I can pull this logistics payload out and put a new payload in, whether that payload be a counter-mine, counter-IED payload, or some other manipulator arm, etc. We can swap it out quickly. The goal here is we found that by the time we develop a solution for the troops, they usually have found a new threat they need to handle and need to deal with. So if we can make the system modular and rapidly adaptable, they can handle that in the future quickly and safely.
And what are some of the adaptations you guys are looking at? Is it a blade for construction applications? Is it, what are some of the different sorts of applications? Something in this size range, right? Everybody understands sort of the little things, but in this size range, what are the vast range of things that you guys envision a vehicle like this doing in service?
So what we're trying to do here is really provide that base truck. And while we have some vision of systems, counter-mine, counter-IED payloads, roller rakes, blades, like you've mentioned, as well as chemical sensors carrying higher-end mass spec instead of sensors like the CBRN sensors on our smaller Talon, we also want to provide the ability for other companies and the government to develop new payloads as they see the need for them in the future. So we've actually used the IOP protocol, so an open interface to allow control systems and payloads to interface with our vehicle without us having to do that integration, such that down the line, the soldier is always getting that hardware that they need.
Talk to us a little bit about the performance parameters of the vehicle, propulsion system, range, overground mobility. What are we looking at for a system of this size, weight, and shape?
Okay. Yeah, so the system was developed to be able to handle all the terrain that your dismounted troops are handling today. Obviously, there's going to be some limitations. Some really advanced troops are going to be into some terrain that a vehicle just can't go in. But 60-degree slope, or 60% slope, sorry, 30% side slope, forward up to 2 feet of water. This system is very unique in that it's got a really high center of gravity, or low center of gravity and high ground clearance. So it can traverse a 18 to 24-inch object in the center without dragging along the ground. The system is a diesel-electric hybrid. It's a series hybrid, so the diesel engine charges a battery pack, and that battery pack then drives the drivetrain here. The system can run with the diesel engine both on or off. So when you need a lower noise signature for tactical operations, you can turn the diesel engine off, you can turn the cooling fans off, and maintain that minimum noise signature possible.
And what sort of range, payload are you guys shooting for? How much payload can you carry, and what's the rough range at a given useful speed? And how fast can it go, by the way?
Okay. So first off, the system can go up to about 15 miles per hour sprint speed. It's got a payload of over 1,500 pounds. The SMET program, which we've targeted with this, has a requirement of 1,000 pounds, but we found our soldiers always need to put something more on it, so we wanted to give them some overload there so that it's still capable for that mission. It has a 60-plus mile range, so really the limitation there is how much fuel you're carrying with you at the time. We recently just completed a test of over 60 miles in under 72 hours with the U.S. Army just last week.
And is that the full range, or does it have longer range than that?
It has longer range than that. So that was just that specific mission profile we were testing. It's really how much fuel can you carry on board. So we spec it at about over 100 miles with the typical loadout of fuel cans.
And how soon do you expect a decision from the Army, and when do you expect a program?
So right now there is a directed requirement for the estimate program, and they expect to do an initial down select to 4 companies for a 1-year user assessment in the next few months.
What are the keys to autonomy for because there are 2 modes, right? It'll follow along with troops and bring their gear with them, I'm sure, which is something that is not as complicated. But in a full autonomy mode, what are some of the challenges, especially for a vehicle of this size class? Generally, when we think of autonomy, we're thinking about smaller things, not necessarily something like this in an overground capacity. What are some of the challenges you have to deal with when you're trying to get this thing to go and do things on its own and get somewhere, especially over rough terrain?
So the biggest challenge right now is actually the cost, and the cost the customer is willing to pay for that. We've been very lucky the past few years. Sensing technology has really advanced, especially because of the automotive market. And there's a wide variety of 3D sensing technologies out there to get a good handle on the terrain and get a good localization of where the system is. But those sensors are not yet cheap. That price is coming down, though, with the automotive market. And I foresee that being pretty advantageous in the next few years.
John, thanks very much. Best of luck on the program.
Perfect. Thank you very much.